Hello middle 3. Now let's start lesson 2, which is called graphical representation of moving in straight line. In this lesson, we are going to study the importance of graphs and tables, and why did the scientists or the physicists use mathematical relations such as graphs and tables, and why it's important to deal with physical quantities and mathematical relations. Okay? In this lesson, we will study the graphical representation of the two types of speed, which are uniform speed and non-uniform speed. But before we study each type of speed, let's first talk about the importance of the graphical representation. Here in question number 1, give reason. It's important to deal with physical quantities and mathematical relations. Why? It's very important to understand the physical phenomena which represent the greatest part of our life. The physical phenomena is very important, and it's represented by the greatest part of our life. It's important in our life. So to understand it, we use the physical quantities and mathematical relations, such as مثلا speed. We use speed to understand the motion, okay, to describe the motion, as we said in lesson 1. Number 2, physicists use mathematical relations like graphs and tables in many physical phenomena. Why? This is because of 3 reasons. Number 1, to predict the relation between certain physical quantities, such as مثلا the relation between speed and distance, speed and time, and so on. So we use the graph, we use the table to predict the relation. Number 2, to understand the practical results, to understand why this car is faster than the other car, and so on. Number 3, to describe physical phenomena in an easier way. To describe مثلا the speed best in an easier way, in a way that I can understand. Okay? This is the importance of the graphical representation. Now let's start studying the graphical representation of each of types of the speed, uniform speed and non-uniform speed. Number 1, uniform speed. Uniform speed is represented graphically by 2 ways. Number 1, distance time graph. Number 2, speed time graph. What's meant by this? Distance time graph is the graph that's represented by distance on the y-axis and t or time on the x-axis. Speed time graph is the graph represented by speed on the y-axis and time on the x-axis. The time is always represented on the x-axis. You have to know this, that the time is always represented on the x, or designated on the x-axis, while the distance and speed are on the y-axis. Okay? Let's start number 1, the distance time graph. Let's take an example and start drawing. Look at this table here. A toy car covered distances at time intervals as shown in the table. Number of trial 1, 0.4 meters distance in 5 seconds. Number 2, 0.6 meters in 7.5 seconds. And number 3, 0.8 meters in 10 seconds. Number 4, 1 meter in 12.5 seconds. Now let's represent it on a graph. Let's draw the y-axis and the x-axis. Okay, we have 0.4, 0.6, 0.8 and 1 on the x-axis, which are represented by this, or designated by distance meter, unit per meter. I have to divide the graph by the simplest form. So I will start with 0.2, 0.4, 0.6, 0.8 and 1. Okay, and the time by second, unit second. Okay, it will be designated by 2.5, then 5, then 7.5, then 10, then 12.5. Right. Why did I choose 0.2, 0.4 here and 2.5, 5, 7.5 here? That's because of the table. The table is, or the numbers which are given to me is like this. So I have to put them in the easiest way. So now let's put the points. 0.4 and 5 seconds. 0.6 and 7.5. And 0.8 at 10 seconds and 1 at 12.5 seconds. What do you see here? Yes, it's a straight line passing by the origin. What's the origin? The origin is the intersection point between the y-axis and the x-axis. The origin point is the intersection between the y-axis and the x-axis. And always the uniform speed distance time graph will be represented by a straight line passing through the origin. Why? Because the body covers equal distance in equal time intervals all the time. Okay? All the points will lie on a straight line. The distance is directly proportional to time. Distance increases with the increase of time. So it's directly proportional to time. This is conclusion number 1. Conclusion number 2, the slope of this line, ratio between distance and time is constant. This slope represents the car speed. What's the slope? This is the slope. This is called the slope. Y, the ratio between distance and time. أو y divided x. Y-axis, point on y-axis divided on point on x-axis. يعني السلوب equal to distance over time يعني equal to v أو speed اللي هي uniform speed. The car moves at regular speed. It's all the time when you divide it 0.4 by 5, when you divide 0.6 by 7.5, 0.8 by 10, 1 by 12.5, all these points will give you the same number, which is 0.08 meter per second. So this means that the slope here is the speed, which is uniform or regular speed, equals 0.08. Therefore, the body of the car covers equal distance at equal periods of time. Okay? This is graph number 1, our presentation number 1 for the uniform speed by the distance time graph. Okay. Let's see now the representation number 2 of the uniform speed, which is the speed time graph. Okay, we will draw also the x-axis and the y-axis. Okay, the y-axis will have the speed meter per second. The x-axis will have the time as usual, which is unit is second. Okay, يبقى v on y-axis and t on the x-axis. Let's put the point with the same table. Okay, the same table. I have the points. Time 5, 7.5, 10 and 12.5. The speed is all the time 0.08, 0.08, 0.08, 0.08. It's not changed because it's uniform speed. Let's draw it. 2.5 here, 5, 7.5, 10 and 12.5. Okay, and here 0.02, 0.04, 0.06 and 0.08 and 0.1. Okay, let's put the point, the 5 at 0.08. Let's put the point with another color so it's clear. And the 7.5 also at 0.08, the 10 at 0.08, the 12.5 at 0.08. So, as you see here, the points is like a straight line. The points lie on a straight line. But this straight line, does it pass through the origin? No, it doesn't pass through the origin. But it's parallel to the time axis, or the x-axis. It's parallel to the x-axis. The representation of the uniform speed of the v-time graph. Okay? The conclusion, the speed remains constant as the time passes. As the time passes from 2.5 to 5 to 7.5 to 10 to 12.5, the speed is regular all the time, it never changes. Okay? So this is very important. You have to learn this, that the speed time graph for the regular speed is straight line parallel to the x-axis, and the distance time graph for the uniform speed is a straight line passing through the origin. You have to remember this too, because they are not changed. Okay, they are one. يعني they are one shape. يعني they are not changed. Okay, let's see another graph, and I want you to tell me what do you think about this graph. This is a distance time graph. Okay, and it's like this. It looks like this. Straight line parallel to the x-axis, or the t-axis, the time axis. Do you think that this is represent what? Does it represent uniform speed? No, it's not uniform speed. Why? Because the uniform speed is represented by straight line parallel to x-axis, but speed time graph, not distance time graph. Like, what's mean by this graph? This means that the distance is not changed as time passes. The distance is constant. This means that the body is at rest. Body is at rest. The distance is constant. It's not changed at all. So take care of what's the name of the graph. And here's distance time. This is the name of the graph. But the other graph was VT graph, يعني speed time graph. Like this. So this is uniform speed. So take care of what's the graph called, distance time or speed time. Okay? Now let's represent the non-uniform speed. It will be represented by two types of graphs, which is distance time graph and speed time graph. Okay, let's start now with number one, which is distance time graph. Okay, look here at the table. He will give me this table, as you see here. It's a graph, distance time graph for irregular speed. The distance covered by the body by kilometer is 0, 10, 20, 20, 20, 50. And the time covered, our time intervals by hour is 0, 1, 2, 3, 4, 5. Now let's represent it on a graph. As you see here, distance and time in hours, and distance in kilometers. Okay, let's put the points here. Time 1, 2, 3, 4, and 5. Here distance 10, 20, 30, 40, and 50. Let's put the points at 0 hours. At the beginning, yani, the distance covered was 0. Then after 1 hour, the distance covered was 10 kilometers. After 2 hours, the distance was 20. Then after 3 hours, the distance remained 20. After 4 hours, the distance remained also 20. And after 5 hours, the distance reaches 50 kilometers. Let's join the points. It looked like this. So this shape is irregular shape. So the distance time graph for the irregular speed or the non-uniform speed is irregular shape. As you see, this is the shape that I got from this table, but I can get any other shape, but also it's irregular shape. Let's draw number 2, which is the speed time graph. The speed time graph for irregular speed. Let's draw it. Let's see the table first. Look here. VT graph for irregular speed. Speed in kilometer per hour was 0, then 30, then 60, 20, then 0 again. The time in hours was 0, 1, 2, 3, and 4. Let's draw it. As you see here, I put here the speed, which is kilometer per hour. And then I will put here on the x-axis the time in unit hour. Okay, let's put the points. 1, 2, 3, 4, and 5. Here it's 10, 20, 30. No, let's put it in better way. 20. 40 and 60. Okay, now let's start putting the point. The first point, at 0 hours the speed was 0. Okay, after 1 hour the speed reaches 30. Then after 2 hours the speed reaches 60. After 3 hours the speed was again down to 20. Then after 4 hours the speed reaches 0 again. Let's join the points. This is the shape of the curve. What's this curve? Yes, it's irregular shape. So the curve of the speed, the graph of speed time graph for the irregular or non-uniform speed is irregular shape, such as the distance time graph. So the two graphs representing the non-uniform speed is always irregular shapes. Okay, this is very important. You have to learn the regular speed and the irregular speed. Each one is represented by a style or a shape of graphs. Okay, سواء distance time or speed time. Now let's sum up what we studied in lesson 2. Lesson 2, the graphic representation of moving in straight line. At first, we have to know the importance of dealing with the physical quantities and mathematical relation, which is to understand the physical phenomena. Number 2, why did the physicists use mathematical relations like graphs and tables in many physical phenomena? And this is for 3 reasons, to predict the relation between certain physical quantities, to understand practical results, and to describe the physical phenomena in an easier way. We studied the uniform speed, which is represented graphically by 2 types of graphs, which is distance time graph and speed time graph. Time is always on x-axis, you have to remember. And the distance time graph is a straight line passing through the origin for regular speed, while the speed time graph is a straight line parallel to the x-axis, also for the regular speed. And we studied also the irregular speed, which is represented by also 2 types of graphs, which is distance time graph and speed time graph. And both of them have irregular shapes. So we don't have to memorize the shape of the graph in the irregular speed, because both of them are irregular shapes. Okay, next time we will talk about the acceleration and we will finish lesson 2. Okay, see you next video. Bye.